So thanks so much for being here, and Zach, thanks for organizing this. It's a new adventure in virtual conferencing. Um, I'm Krista Brelsford. I'm a research scientist at Oak Ridge National Lab, and most of the work I'm presenting here today has been done with some colleagues at both Oak Ridge National Lab, Gautam Thakur and Jake McGee, and at Exeter University, Rudy Arthur and Howell Williams. So what I'm trying to do here, the sort of broader theoretical question: what makes a city? What makes a neighborhood? And then a bit slower on, how does urban social structure change, and how can we measure that quickly when big things happen? So what makes a city? I don't know if the internet connection is well enough for you to see this GIF, but this is Las Vegas's growth between 1972 and 2014. You can, if you can see the resolution to understand how a city is changing dynamically. And this problem sort of understanding how digital trace data, like tweets, understand spatially embedded communities. So there's a data platform at ORNL called Planet Sense that has that shows that scrapes a bunch of geographic information, some of which is tweets, and then we can use that to build a social build a network among people who are communicating with each other on Twitter, and then spatially embed that. I see that somebody in the chat is saying that they can't hear me well. I hope that, well, just keep speaking up if the audio isn't coming clearly. So we all know the caveats that come with Twitter data, but digital trace information is the first and only large-scale method available right now for sampling human social processes. And so the results I'm going to present here, I'm not claiming that they're a be-all and end-all, but I think they're a first stab at a strategy for starting to try to understand how who we communicate with is embedded in space, and that gives us a way to understand how our communication patterns and our social structures interact with our geophysical world and current events. So to give you a clear understanding of what I mean when I say a place tagged tweet, it's not necessarily a point location. It's not even necessarily a user's true location. Most often it's a bounding box around something like a point of interest or administrative boundaries. So these screenshots here from my phone are what I see if I were going to try to tweet from my house. There's a dog park nearby. Mrs. Curitan is a kindergarten teacher who lives down the block, who happens to tweet a whole lot. And then I could also tag myself in broader locations, either Oak Ridge, Tennessee, or nearby communities, Farragut, Knoxville, etc., or broader regions like the state of Tennessee or the United States more generally. So the geographic information that I'm using is not necessarily very precise, and that has some implications for the minimum spatial resolution of the methods that we can use. But to walk through the method that I'm using carefully, I create an aspatial network of direct Twitter mentions or retweets. Again, this is the public information, it's not direct messages. And then aggregate those tweets into grid cells, giving a spatial grid of nodes and edges that represent people tweeting from, or users tweeting from the same location to another location. And then that spatialized network, we can run really standard community detection algorithms on it and understand sort of how communities are structured. So using a data set of 72 million tweets from the United States, we find something like this, where nodes are colored to correspond with a community that they've been identified in. Now, this community detection algorithm so far has no geographic information in it. So it's interesting that the communities that we find really are geographically consistent, or sort of geographically reasonable, right? They're pretty consistent with the major regions of the US Census. to sort of make that more geographically specific, here's all of the grid cells that have information when I use a 72 million tweet data set. And you can see sort of the most interesting feature to me is that the Northeast is connected to Florida, where all of the other regions, you've got the West, you've got, you know, Texas and Louisiana, the South in dark blue, and then we can perform a sort of pretty simple geographic smoothing algorithm on this to make our regions just a little more spatially coherent, which then enables us to zoom in to particular regions. So here's the US South where I live. And you can see here in the communities on the right side of the screen that the communities we find now are generally pretty consistent with states, except for in a few cases that make sense. Memphis, Tennessee, which is the city in the lower left-hand corner of Tennessee, is in light blue. It's more connected with Mississippi, which really makes sense given sort of what we know about much of the racial and economic ties between those regions. And then if we look in the Northeast, we see Northeast and Florida, where I'd previously pointed out that Florida is really consistently connected with the Northeast rather than, say, the South, where we just looked. There's a lot of mobility, migration, tourism, and economic ties between Florida and the urban Northeast. But when we look within that region, we see again pretty Florida becomes its own community, and you can see the ties between different regions. These colored regions are, you know, reasonably consistent with the major metropolitan areas that we see in the Northeast. So this method, you know, nothing I've presented here is earth-shattering, but at least at the United States regional level, it seems relatively consistent with our understanding of how people communicate with each other. And it's neat that we can find that using only tweets, only who's talking to who on Twitter. So then the next thing I wondered was, okay, well, what's the minimum spatial resolution we can get here? Can we look at neighborhoods? So I picked a couple of global megacities with a range of data availabilities to look, then instead of looking at the entire nation, just to look within that city. So Hong Kong is a globally important city, but we know most people in China don't use Twitter, they use Weibo. And so the data availability in Hong Kong really isn't nearly as good as we'd expect for other cities. In Hong Kong, the data set that we had scraping data for a year only gave us 224,000 tweets. And when you collapse that down into the usable tweets of people tweeting in the right place, who are tweeting to somebody, and the somebody that they're tweeting to also has geographic information that locates them with sufficient spatial resolution in Hong Kong, that network gets really small. It goes down to only a couple thousand users. But you know, we can run our algorithms anyway. So this is a map of Hong Kong and Shenzhen with the tweets located by the centroid of the bounding box that they're located. And there's not a lot of geographic resolution in these tweets, and you can see the tweets are all coming from Hong Kong. They're not coming from mainland China really at all. So, you know, run our community detection algorithm. We find something. We find communities. We're guaranteed to find communities because it's a network-based community detection algorithm, so it's always going to find something. I've never been to Hong Kong, so I don't really know. I don't know, and I don't really expect these to be super interesting because I don't think we have sufficient quality data to say much. But that's what we found. Then moving to Bangkok, where we have 6 times as many tweets. This is a data set, again, collecting data for approximately the same time period, 127 million tweets, again, many more users. And our sort of collapsed down network of users who are in the right place, tweeting with the right spatial resolution who tweet at somebody who is also tweeting from the right place with the right spatial resolution. The network we find then has, you know, tens of thousands of users. And that's, you know, more interesting. So here's a map of where all the tweets that we're observing, where they're originating from. This is, again, the centroid of the tweet bounding box. And so, you know, not surprisingly, most of the tweets that we see are in the middle of the city. The communities that we find, again, so far I don't have super great strategies for validating these, although Thomas's talk has given me some good ideas that I that I think might be interesting to compare this information in a systematic way. So you know, these are some of the communities that we find. If we sweep the parameters, so we can include tweets of different geographic resolution, eventually we run out of data if we use super fine scale data, or if we only use the finest, most finely resolved tweets. We still have enough information to describe communities within the center city area, but it's hard to exactly know what that means. Similarly, we can change the geographic resolution of our grid cells, either twice as big or half as big, and see, you know, in some places there's similarities, and in some places there's differences. If we move to Rio, then this is a data set. Brazil is a country where Twitter is very heavily used, and so we thought Rio would be a good place to look to see what we find with probably as rich as possible of a data set as we'll get from Twitter. So this data set has 13 million tweets, and on the order of hundreds of thousands of users in our final network. Here's a map of where tweets are. And one interesting feature for Rio compared to the other cities is that you'll see in the center, or in the sort of oldest and most established part of Brazil, or Rio, which is, well, here's a map that zooms in on it. This is population density. Here's sort of where Rio was originally founded. You can see both that there's substantial heterogeneity in population density, but there's also a lot more geographic variability in where tweets are coming from. And that's because people are using more finely resolved tweets. And that gives us higher geographic resolution. So I've got more confidence in the meaning, in what the Rio results mean than what other results mean. So this is Rio's population density. Here's Rio as a whole income. You can see one interesting feature is that the beaches, famous, wealthy beaches that you always see in all of the tours and pictures of everything. But then if you zoom in again on the same area, you can see that there's still substantial income heterogeneity. There's substantial income heterogeneity at resolutions that are even finer than the sort of grid cell based communities that I'm using. So looking, if we keep only the very smallest tweets, here's the communities that we detect. They're, you know, sort of consistent with economic and geographic patterns, although I haven't done a formal validation. You can include more tweets by changing the geographic resolution. And get a broader set of information, but you also sort of lose the information contained in the really finely resolved tweets because they get swamped by the many people that are saying, oh well, I'm tweeting from Rio. Again, you can change the resolution, and so that's interesting. But one thing that now I've been thinking about recently, because we're all from home, because this is virtual, what I'm working on right now is trying to think about how I could use this to understand changes in social structure in response to, say, COVID-19. So obviously we have to figure out some validation, but because this is tweets, we can observe this for essentially arbitrary spatial and temporal resolution, and that becomes really important if we're trying to understand how behavior is changing in response to in response to all of the various stay-at-home, shelter-in-place kinds of orders that pretty much everyone everywhere around the world is under. So this is a map using data from Descartes Lab, looking at when mobility in the United States by county dropped below 2 miles. This is a map of when public schools were closed by either their state or county government. And then what I'm working on doing right now, but don't have a panel to show, don't have a map to show you, is how the United States, how sort of community network structure in the United States has changed around those different time periods. Okay, that's my talk. Thank you.